A few years ago, I created a very simple audio synthesizer using Pygame. It wasn't pretty or very functional, but it served as a foundation for understanding how to create sounds in Python using NumPy and Pygame, and above all, it was fun to do it. So I decided to build an improved version, with a more advanced interface and greater control over sound creation, without needing to change things directly in the code, making it way simpler to use. On top of that, I wanted to make it web compatible, something I had already tested briefly with the previous version, but also capable of composing music with multiple tracks using a tracker, similar to Bosca and other similar software. So after a few weeks of off and on development, I present to you my new and improved synthesizer, the SynthFET 3000, to commemorate my current subscriber count. The first thing you see when you open it is the splash screen actually. Then the second thing is the keyboard interface, where you can play different notes using your physical keyboard or your fingers if you are on a touchscreen device. I guess you will use your fingers either way, but you get the point. I chose a traditional piano layout here to make it easier for people who already have some music knowledge. It also helps if you are following a piano tutorial or something similar, so you will feel right at home. If you want to change the note range, you can do that using the left or right arrow keys on your keyboard or the buttons on the top corners of the screen. As you can see, the idea here is to emulate a real keyboard, letting you try to play a song directly while looking at the keys, which have two kinds of labels, one with the note for each key and the other for the corresponding key on your QWERTY keyboard. And when you have a physical QWERTY keyboard connected, you will also be able to play notes from any of the other screens, which I will introduce next. The second screen is the wave editor, where you can draw the waveform that will be played. Yes, what you see is what you will hear, and it is kind of fun drawing different shapes of waves to hear how they sound like. I also added buttons at the bottom for predefined waveforms like sine, square, triangle, sawtooth, a piano, which is just a random irregular wave that sometimes sounds piano-like but usually doesn't sound anything like a piano. And finally, a completely random waveform, i.e. noise. There's also a smoothen button to soften the waveform drawing, since it's hard to manually draw a smooth curve. After you are done handcrafting your wave, to generate the sound samples and test out the new waveform, you must hit apply or change the screen. If you haven't seen my first video and you are wondering how I'm doing all of this in Pygame, the short answer is the SND array module, which turns NumPy arrays into sound. The arrays are created using NumPy functions, first to generate the waves, but especially to resample them at the frequencies of different musical notes and apply effects. The long answer is that you should watch my old video. Now back to the subject, the goal of this screen is to let you experiment with any kind of sound, even try to emulate real instruments by copying their waveforms. Unfortunately, the real world is a bit more complex than that. Some instruments can probably be replicated reasonably well, but I suspect their waveforms changes with pitch and over time, so it might sound good in some notes, but not on others. Still, I find drawing the waveform is a very intuitive way to explore sound design. The next screen is the envelope editor, which shapes the volume over the duration of each sample. For example, wind instruments usually have a more or less constant volume over time, while some string instruments like a guitar have a strong peak at the beginning and then decay. You can draw the envelope however you want on this screen, similar to the waveform editor. It will be scaled with the duration of each sample. Again, the buttons at the bottom provide predefined shapes, like ADSR, attack, decay, sustain and release. It's supposed to be some sort of standard envelope. Ramp starts high and decreases linearly with time. Plucked is similar to ramp but decays a bit faster. Noise is just noise again. Fun fact, if you combine it with the noise wave, it sometimes sounds just like the blue screen of death from Windows. Then we have tremolo, which actually is an effect that applies a modulation to the current envelope. Its frequency is adjustable in the options screen. And a smoothen button, similar to the wave editor one, to remove sharp corners from the envelope. And also similarly, you need to hit apply to actually try out the new hand-drawn envelope. But it's easier to test it with a physical keyboard connected, so you don't have to go back and forth. Now before we go to the tracker screen, let's go over the options screen to take a peek. Here you can configure number of keys, can be used to change the size of the keyboard on screen. Sample duration, how long a sample can last if you press a key. Sustain controls how long a note keeps playing after you stop pressing a key. Then you can add reverb or overdrive using the effects button. Reverb adds echoes to the samples, while overdrive quadruples the signal and then clips it back. They don't sound very realistic, but they are fun. And as I mentioned earlier, you can adjust the tremolo frequency here. And same as the other screens, hit apply to regenerate the samples. On the right side, you will find 6 instrument slots that can be used in the tracker, or they can be copied to the editor, replacing the current waveform, envelope, configuration, and effects. Or you can save your current settings into a slot, overwriting the previous instrument. The instrument's name comes from the last waveform you generated, like square, sawtooth, or noise. Only the pre-existing ones have some funny names. Now last but not least, we go to the tracker screen, where you place notes by clicking anywhere on the grid to play them in a sequence for creating sounds. On the side are several buttons. First the play button, which is actually 2 buttons in one. Left side plays the section currently visible on the screen, while the right side plays the entire song. The currently playing column is highlighted, and if you play a note via the keyboard, the corresponding row is also highlighted. While playing, the play button changes to stop, and if you click it, it stops. The second button is the instrument selector for the current track. The default order follows the track order. Track 0 with instrument 0, track 1 with instrument 1, and so on. But you can change it however you want. The next button is used for section navigation. If you are on the last section, ++ appears to let you add 8 more notes to the song or half a screen. You can create a very long song, and the markers on the button help keep track of where you are with the current start bit, end bit, and total number of bits. Then we have note range selector to shift the higher or lower notes to be displayed on the screen. The BPM button is used for tempo control by setting the beats per minute. Each beat contains 4 notes. This I got from Boskakiol. It might feel weird at first, but I guess it is some kind of standard. Next is the track switcher. Each track has its own instrument, but you can assign the same instrument to multiple tracks if you want. The notes placed on one track will also be highlighted discreetly on the other tracks. If you want to start over, you can use the clear button, where you can clear the current track or the entire song at once. And when you are satisfied with your song, you can use the export button to export your entire song with all tracks or just a single track to a WAV file. Empty tracks are ignored, and non-empty tracks are saved as separate channels in a single WAV file. This way you can mix them more precisely on an external audio editing app like Audacity. There is still a lot that could be improved, but I think it's already good enough to test some ideas and create fun songs. Compared to my first synthesizer, the difference is huge. Maybe I can actually use this one in future projects to make some simple soundtracks. If you are interested, you can test it on itch.io or install it as a progressive web app via the GitHub pages link. The source code will also be available. I decided not to go too deep into the implementation here, since some parts may still change. But if you'd like a more technical video about how the synthesizer works, let me know in the comments. Hope you enjoyed it. Cheers, see you in the next video.